Next, we're looking at transformations of log functions. So this sheet is a reminder of the different types of transformations that we've already seen. Remember, if it is grouped with the x, looking at the horizontal shift here, it's inside the asylum, meaning it's not normal. It doesn't do what you think it should do. So if it looks like it's shifting left, it's shifting to the right. If it looks like it's shifting to the right, it's really shifting left. Vertical shifts are outside the asylum. Notice they are not being grouped with the x. That would move the graph up or down. And if they're outside the asylum, they're normal. So adding does go up and subtracting does go down. And then the two different types of reflection. Again, if it is not grouped the x, it's a vertical reflection or across the x-axis. If it is grouped with the x, it's a horizontal reflection or across the y-axis. Our first equation, the first thing that we want to do is identify the different types of transformations. So the negative on the outside, not grouped with the x, is a vertical reflection. The -1 grouped with the x looks like it should shift to the left, so this is a shift to the right because it's not normal. And then this +2 is on the outside, not grouped with the x, so it's normal, so we're going up 2. Domain of a log function, you can't take the log of a negative or a 0 because you don't get an answer of negative or 0 from an exponent. So we set what we're taking the log of to be greater than 0. Solving for x by adding 1 to both sides, our domain is x needs to be greater than 1. Range, flipping that around from the exponentials, because the domain of an exponential is all real numbers, the range of a log will be all real numbers. Our exponential functions have a y-intercept, so flipping that around, our log functions will have an x-intercept. So we set the function equal to 0 and solve. So the first thing I'm going to do is subtract 2 from both sides. Dividing by the negative sign outside the log. Using curly law, 4 squared equals x minus 1. 4 squared, of course, is 16. So adding 1 to both sides, we get an x-intercept of 17. So we solved and got 17 when our y value was 0. The asymptote depends on a horizontal shift. So think about for the exponential functions, our asymptote depended on a vertical shift because we had a horizontal asymptote. With logs, we have a vertical asymptote, so it depends on a horizontal shift. We went right 1, so our asymptote will be x equals 1. So what I'm going to do is, instead of doing the 4 to the x power, I'm going to think about the 4 to the x, and I'm going to write my log base 4 so that I can use my second t-chart for the transformations. And what I'm really going to do is I'm going to do 4 to the x, but I'm going to put those answers for my x, and the inputs I'm going to use for my log. So we've got our inputs of -2, -1, 0, 1, and 2. 4 to the -2 is 1/16. 4 to the -1 is 1/4. 4 to the 0 is 1. 4 to the first is 4. And 4 squared is 16. So these are my log values. Remember, it's the inverse of the exponential, so the x and the y switch places. So it's an easy way to get your log function set up. In the second one, this will be my transformation. So we'll look at all of those pieces of the transformation that we first identified. A vertical reflection will multiply my y values by a negative. Up 2 will add 2 to my y values. And shifting it right 1 will add 1 to my x values. So I'm going to take that first t-chart. 1/16 plus 1 is 1 and 1/16. 1/4 plus 1 is 1 and 1/4. 1 plus 1 is 2. 4 plus 1 is 5. And 16 plus 1 is 17. So to get my y values, I'm going to take the y values that I got in my first chart, make them opposite, and add 2. So the opposite of negative 2 is 2, plus 2 is 4. The opposite of negative 1 is 1, plus 2 is 3. The opposite of 0 is 0, plus 2 is 2. The opposite of 1 is negative 1, plus 2 is 1. And the opposite of 2 is negative 2, plus 2 is 0. So the x-intercept that we solved for to get 17, 0 matches the x-intercept that we just got in our t-chart. So because we're consistent, that's a great sign. Because I'm not going to fit my x-intercept on the graph anyway, the other x values and y values all fit within 5. So I'm going to scale each of these by 1, which means this first one will be my asymptote. We had a vertical asymptote at x equals 1. And then we can plot the points from our t-chart. 1 and 1/16, so just a little bit more than 1, and we'll go up 4. Next we had 1 and 1/4, and we'll go up 3, 2, 2, and 5, 1. Remember, it's important not to curve away from your asymptote, so you want to start on the asymptote even, and then curve towards your other points to get your log function. So, compared to our parent function, this log function has a vertical reflection. It was flipped across the x-axis, shifted to the right 1. We can see that with the shift in our asymptote, and up 2. Let's take a look at one more. This time, because we have multiplication by the x inside the asylum with a shift, we need to factor that out before we can use our asylum analogy. So when I factor the negative out of the x, factor any scale change or reflections out of the x so that you can see what the transformation is, right or left. So the negative is a horizontal reflection. And now after factoring out the negative, we have a -3, which means we're going right 3. So our domain, setting what we're taking the log of, and I'm going back to the original function where it's not factored out, greater than 0. And this time, in order to solve, I'm going to add x to both sides. So I get 3 is greater than x. Or if we flip it around so that the x value is first, x is less than 3 is our domain. So x is less than when we have a horizontal reflection. X is greater than if we do not have a horizontal reflection. Range for logs is all real numbers. X-intercept, setting the function equal to 0 and solving. So 0 equals log base 3 of negative x plus 3. You only need to factor that negative out when you're identifying the transformations. Here, I don't have anything on the outside to cancel, so I'm just going to start right away with my curly law. 3 to the 0 power, which is 1, equals negative x plus 3. Subtracting 3 from both sides and multiplying by a negative, we got an x-intercept of 2. So we solved and got 2 for x when our y value was 0. Asymptote depends on a horizontal shift. We had a horizontal shift right 3, so our asymptote will be x equals 3. Same thing I did on the last one, we're going to have this be our log function. And the second t-chart will be our transformation. So starting off by putting x values in under the y column, which is an easier way to evaluate logs, we get 3 to the negative 2 power is 1 over 3 squared, or 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. So now we're going to take those values and transform them for our new graph. We had a horizontal reflection, which multiplies our x value by a negative, and shifting right 3. So we will add 3 to our x. So all of those y values will be left alone. We had no vertical transformations. So the x value is the opposite of 1/9 is negative 1/9 plus 3 gives us 2 and 8/9. The opposite of 1/3 is negative 1/3 plus 3 is 2 and 2/3. The opposite of 1 is -1, plus 3 is 2. Opposite of 3 is -3, plus 3 is 0. And opposite of 9 is -9, plus 3 is -6. We're going to start with our vertical asymptote. I'm just going to leave that last point off the graph so that I can scale each of these by 1 again. That'll still be enough points that we can see what's going on with our transformation. So vertical asymptote at x equals 3. And then we'll plot the points in our t-chart. So we have 2 and 8/9 are just shy of 3, and we'll go down 2. Second point is 2 and 2/3, -1, 2, 0, and 0, 1. Starting close to or even on your asymptote so that you don't curve away from it. And connect your points.